Now, what do you do when you want slopes and tangents and you have parametric equations? It turns out the formula is actually quite straightforward. The derivative of y with respect to x for parametric equations is the derivative of y with respect to t divided by the derivative of x with respect to t. So the slope at any point is given by this ratio. Now I want to do a fairly simple example to start with. Suppose y is, oh I don't know, 2t squared, and x is t cubed. Then what is the slope at any given point? Well, the first thing you need to do is find dy dt, and that is 4t, and then find dx dt, and that is 3t squared. So that then I'm going to come up and find the slope. When I find the slope, it is going to be dy dt, which is 4t, divided by dx dt, which is 3t squared. And I am going to simplify this. That's 4 over 3t. So that's the slope at any point. Now, a lot of times we do want higher order derivatives. So if I want the second derivative of y with respect to x, that's the derivative with respect to x of the first derivative. So if I take this and substitute it in, here I get that the derivative of y with respect to x, the second derivative, is d dt of dy dx divided by dx dt. Now what I recommend you do is you just sit and make a chart and do these one at a time. To do the third derivative, you're going to take the derivative with respect to x of the second derivative, and that becomes d dt of dx dy squared dx squared divided by dx dt. You can get your tongue tied doing these, so be a little bit on the careful side. Let's do an example. Now what do you do when you have a situation like this? And we're going to take a couple of derivatives here. The first thing I'm going to do is find the derivative with respect to y of t. So this is 2 times 1/4 is 1/2 t. And the derivative with respect to t of x is 1/2 t to the minus 1/2. It's hard to see. And what that tells me is the derivative with respect to x of y is a derivative of y with respect to t divided by the derivative of x with respect to t. So it's the ratio of these two. It's 1/2 t divided by 1/2 t to the minus 1/2, or t to the 3/2. Now, suppose I want the second derivative. Well, the first thing I need to do is find the derivative with respect to t of dy dx. So that's 3/2 t to the 1/2. So now, when I want to find the derivative, the second derivative of y with respect to x, this is the derivative with respect to t, and you don't have to put this step here and there, but I do, of dy dx, which is what I have right there, divided by the derivative with respect to x, the derivative of x with respect to t. I know I get a little tongue-tied saying this. So what is this? This is this term right here, 3/2 t to the 1/2 divided by 1/2 t to the minus 1/2, or let's cancel, I'm left with 3t. So as long as you keep them straight, and I usually just make columns, it helps me, then you'll be fine. This is actually a kind of a fun unit.